automatically your gripper will close. If you extend this, then automatically your gripper or your finger will open, right? Yes. So this is your diagram, schematic diagram, and you have two fingers and two links. So both are geometrically symmetry. If you take this as your center axis, this side and this side is geometrically symmetry. The dimensions, the shape, and the angle of your links all are same. So now for doing my analysis in easier way, I will consider the half of this gripper only, then I will multiply with 2, then I can able to find out the total actuating force that we will do later. See, I am concentrating on this portion, so the half of the portion, so I have drawn the half of the portion here, right? So here there is a actuating force which is acting, and consider this as link 1 and this as link 2, and here you have a pivoting point. So pivoting point where you have no motion. That is, at this point, the sum of all your forces and sum of all your moments are 0, because this is a fixed point like that, right? So, if this is an actuating force which is acting at a horizontal manner, then I supposed to find out the force which is acting at the link 1. So I will consider that as F. So that is my first objective. I have to find out this F value, that is the force acting on this link, right? And consider this as a right angle triangle. See, this is a right angle triangle. So definitely this will be, this is 90 degrees. So this will be a 45 degree, and this 15 degree also just given, right? Now I'm going to draw the free body diagram for this mechanism, right? Free body diagram means, so you are neglecting the parts and you are neglecting the surroundings. You are only drawing the forces acting on the particular mechanism, right? And this is F. See here. So this is your F. So this is your F. So I am going to resolve this F into a vertical component and an horizontal component, right? So resolution, resolving, the resolving way, how to do a resolving. So for the vertical component, so the angle also, it is 45 degree. So the vertical component will be F sine 45. Whereas the horizontal component, this is your horizontal component, this is F cos 45. So I have resolved this F force into two. One is F sine 45, another one is F cos 45. And I know the dimensions of the link, right? So from the pivoting point to this point, it is 1.5 inches. And this point to this is 4 inches, right? So now I want to find out this horizontal distance. Please understand. So from this point to this point, it is 1.5 inch. That is an inclined length. I want to find out this horizontal length and the vertical length between these two pivot points. Right? So, the angle, right? So 15 degree, which is given in the problem statement itself. So you can easily able to find out this horizontal distance. It's nothing but 1.5 cos 15. In the same manner, you can able to find out this vertical distance also. That is nothing but 1.5 sine 15, right? So in the same manner, find out the distance for this longer link also. You can consider this as link number 3, right? So this particular distance is 4 inch. If you want to find out the horizontal distance, then it will become 4 cos 15. If you want this vertical distance, it is 4 sine 15. That is not required actually, but if you want, you can calculate 4 sine 15, right? Now, my objective is I have to find out this force. And I know one clue, that is the sum of moment about this point is equal to 0, right? So if you add all the moment which is acting at this moment, this pivot point is 0, right? So now I am trying to add all the moments, and you know very well, moment is nothing but force into perpendicular distance. For example, this is a force here. This is Fg is acting, right? This is a force which is acting, which is given in the statement, that is 25 pound. and into the perpendicular distance. This is a force into a perpendicular distance. So 25 into 4 cos 15 about this pivot point, right? Which is creating a clockwise movement. Whereas in the right hand side of the pivot point, you have two forces. One is F sine 45, which is creating anti-clockwise movement. So I have written in the right hand side. So it is nothing
ఈ
but F
ప్రాసెస్
sine
తర్వాత కొన్ని
45. This
రోజుల
is
తర్వాత
your
చేసి ఉంటావు
vertical
ఇది, అందుకని
force
ఫస్ట్ ఈఆర్ఓకి వెళ్ళింది.
into the perpendicular distance up to
తర్వాత
your pivot point
యాక్సెప్ట్
is
చేస్తే డైరెక్ట్గా వెళ్ళిపోతే, లేదా
1.5
ఏఈఆర్ఓకి
cos
వెళ్తుంది.
50. So here I have written F
ఏఈఆర్ఓ
sine
అంటే
45
వెరిఫికేషన్కి
into
వస్తుంది.
1.5 cos 50.
ఇంటికో మరి మాది ఇంకా
Plus,
అవ్వలేదుగా.
again this here there is another force. So which will create a moment F cos
అంటే
45
నాది
into this.
ఎంటెక్ది
This is your
కోయంబత్తూర్
perpendicular
పెట్టాను.
distance up to this given point.
మరి ఏమన్నా
So F cos 45 into
తమిళ్లో ఉంటుంది
1.5
కదా, తెలుగులో ఉండదు
sin
కదా.
15. So if you substitute all the
నీది
values
జేఎన్టీ ఏదో అయి ఉంటుంది,
and
వెంటనే అయిపోయి
finally
ఉంటుంది.
you will get this force as 74.4 pounds, right? Uh, so because you have resolved this F force into 2, and final objective is you have to find out this F. Once you know this F value, right? Once you know this F value, you can able to find out the actuating force. So once you know F value, you just multiply with 2 because you have two links here, right? So from this you can able to find out the actuating force, right? So I will move to the next step. So this is the part we have drawn here. So there is a force that F is 74.4 pounds. In this remaining portion also the same force is acting because this is having a geometrical symmetry, right? So when you transmit your FA to here based on the principle of transmissibility, the FA is acting on the same line of action, then you can construct a triangle and you can able to find out this FA, right? So you just transmit this FA to here. So 74 FA and the angle 45 in 1. So from this you can able to find out this FA. So cos theta is equal to adjacent by hypotenuse. So you know adjacent is FA and the hypotenuse is 74.4, and I have multiplied 2 here. So in order to consider the remaining of also, so that totally you have to apply 105.2 pounds to this mechanism. So this has the input value for selecting your actuator, right? And this is actually an actuating force, right? The first step. So I will repeat again. The first step is you have to find out the gripping force, and the second step you have to find out the actuating force. Once you know the actuating force, you can able to select the respective gripper from the manufacturer catalog, right? So this is an catalog I have downloaded from the company called Magnum. They are pioneer in selling, manufacturing and selling the mechanical type of grippers. And here they have mentioned the body, that is the material they are used for manufacturing the gripper. Sometimes they may use aluminum, sometimes they may use polymer based grippers also. So based on your environment, your requirement, whether it is subject to some heated environment or extreme environment, then you choose aluminum. If it is not an extreme environment, then you can go with PET, right? Because the weight gets reduced, right? And the cost also very minimum. And if suppose I want to take a gripper, I want to select a gripper, right? And I know the gripping force is 70 pound, right? Here they didn't mention about the actuating force, so they directly give the gripping force. Gripping force based on the gripping force itself, you can calculate. So this Magnum company, they directly give the gripping force. So in such cases, you don't want to find out the actuating force. If you want to design in your own, then you have to find out the actuating force. Here the manufacturers are directly selling the gripper, so they directly posted the gripping force, right? So suppose I want a gripping force of 70 pound. So in such case, you can select any one of this model, right? So see here, Here it is 29 pounds. The second model is 29 pounds. Third model is 29 pounds. See, but the material is different and even the stroke also different. I will tell you what is stroke after this. And here, see, this will carry 100 pounds. So this is the best choice for your particular application because the gripper force is 70 pounds. So you can select this particular model for suit your particular application, right? And this stroke is nothing but your jaw movement, that is your finger movement. So this can be decided by means of knowing the shape and size of your object. If you know the size of your object, then easily you can select any one model, right? For example, the stroke is 26 mm. Then the thing is the object size or the object you are going to hold size should be less than 26 mm. Then only you can hold. If it is 50 mm in size, then definitely you cannot hold by using this particular model. Then you have to select another model having both it should satisfy both force and also stroke. Right? I hope you understand. And this is the catalog which I have downloaded from the company called PhD Inc. So they are also selling grippers for different robotic company like Motoman, Escava, and ABB. So they have different models like GRA, GRS, GRD. It's all like variants. So each variant or each model has some unique features, right? Some model have the size of the gripper is very minimum. Some gripper size is maximum. So if suppose if you have some space constraint, then you have to select this particular model. If there is a space is not a big constraint, then you can select the GRH model. And each model they have listed the grip force, right? So see here, so GRA can withstand up to 123 Newton, whereas GRS is it can hold up to 1287 Newton and GRD. So each model has some unique features, right? And I have mentioned the jaw travel also. So as like grip force, jaw travel also important, but there is no calculations are required directly. If you know the size of your object, based on this, you can select your particular model, right? So each has plus and minus. It is compact, flexible, designed for large movement capacity and longer tooling. Whereas the second model has high force, rugged jaw support, and sometimes it is this. If you take GRD, it can work for 10 million cycles. You just imagine. So they have given the lifetime also. So each has some unique features. So based on that, you can select your gripper, right? So these are this all about mechanical gripper, right? So if you are ready to buy a mechanical gripper, then you have to code these specifications to the gripper manufacturers. These are all very important, right? So one is you have to mention the grip force required, right? So normally you can grip an object from 0.04 kg to 1000 kg. So you have a wide option. So even you can lift 1000 kg, or you can lift even a robot can lift a car also. That is also possible. So it is more than 10 ton, 20 ton. So just imagine. And the part size also very important. So this is the object size. This is nothing but your object size. So it's approximately speaking, it can go up to 90 centimeters. That is 3 feet. So up to 3 feet you can handle, right? So these things you have to say to your gripper manufacturers, right? So the number of jaws maybe 2 to 4 jaw, and repeatability. This is a very important factor, right? And the repeatability may be 0.1 mm, and most of the gripper costs comes around 7,500 to 75,000. Even if you go with some specific environment gripper, then it may go more than a lakh, right? And most of the grippers are work up to 10 million cycles, right?
ఏం సార్
So
ఎక్స్చేంజ్
after that you
పట్టుకుని
have to replace as like bearing. So you are bearing, you are mentioning number of cycles as like that. For gripper also you have to mention the lifetime, right? So these are all some of the company as I have mentioned in the first slide. It's a PhD, Fairland, Robohand, Robotic Accessories, Magnum, Jtron, even Shunk, and Robotic. They are all pioneer in
ఏం
manufacturing
సార్ మ్యాథమెటిక్స్ సిక్స్త్
mechanical
ఇస్తున్నా
grippers, right? So the next one is vacuum gripper. Uh, so these grippers are operated by using a vacuum, right? So you have to create a negative pressure so that your object can be lifted or grasped. So for that you have to use a vacuum pump or by a compressed air. Right? So by creating a venturi method, you can able to pick your object. So you can handle any type of component, like you can handle a plate or maybe a egg or maybe a paper, wood, maybe any kind of material. So it is completely depends upon the how much pressure, negative pressure you are creating on your gripper, right? So you can handle a smooth component, maybe a irregular component. You can handle a bend, or you can handle a porous material or airtight material. So or sometimes lightweight material. If you want to grasp a glass, if you want to grasp a carton, if you want to grasp a fabric, so you can use a vacuum gripper. So these grippers are very safe. But only drawback in this vacuum grippers are a little bit noisy. But nowadays people are trying to reduce the sound of this vacuum gripper by means of placing some silencer on it. There are a lot of research are ongoing. So sometimes it may be difficult to hear. It may cause a lot of issues for the workers, those who are working in this particular environment. They feel very disturbed, right? If they hear these sounds. That is the only drawback you can feel this vacuum type gripper. And this is a gripper which is used for holding a small and medium object, right? If suppose if you want to grab some uneven object, you can use these types of gripper. If you want to grasp a large and heavy object, you can use these type of gripper, or you can use multiple suction cup also. That is again based upon the weight and size you are going to handle. See, in this also, you have to find out the lift. You have to find out the pressure you have to give for your suction cup, right? So the lift capacity of the suction cup depends upon the effective areas, right? So this is your effective area, your suction cup effective area, and the negative air pressure between the cup and object, right? Suppose you want to lift a 10 kg carton, right? You just imagine you want to lift a 10 kg carton. You have selected already, you have one gripper, the size may be the cross sectional size may be a 20 mm square suction cup. Then you can easily find out this pressure, how much negative pressure you have to create. So once you know the weight, you know the cross sectional area of your cup, then you can able to find out the pressure, right? The very simple formula. You can easily find out the pressure you have to use for grasping your object. If you want, if the application is a critical or sensitive application, then multiply with some factor of safety. So I already said you can use 1 to 2, right? That is the range. So then it will become double. So you have to give more negative pressure so that there will be no failure will happen. So the objective to grasp your object will be fully satisfied. And these are all some of the common specifications of a vacuum gripper. So the gripping force is generally up to 300 pounds, and maybe you can use multiple cups also if you want to hold more than 300 pounds. For example, if you want 6,000 pounds to be handled, then you can use multiple cups, right? And the pressure maybe ranges from -3 to -15 psi, pounds per square inch. That is a gauge pressure. And the suction cup ranges from 0.05 to 18 inch in diameter. right? So 1 inch is equal to 2.54 centimeter. Please convert. And the cost of the suction cup is very minimum. So it is comes around $10 to $500. It's just an elastic material, a rubber material, right? And the supporting technology means you have to create a vacuum. No? So for that you need some compressors, some lines, some valves, some air filters, even a controller, even a silencer. So this costs huge in a suction cup assembly. So it will comes around $500 to $2,000, right? So these are all some of the companies they are pioneer in selling uh, vacuum gripper, Yap, Bacon, and all back. These are all the companies. Even Sunk also they are supplying. Roboworks also supplying. Robotic also supplying these vacuum grippers. Right? So I think before go to the selection of gripper, maybe we'll have one video how the gripping was done by a mechanical gripper and a vacuum gripper. Stop share my screen. Ma'am, is my screen is visible?
Yes, sir.
So this is a kind of gripper to grasp an object. It's actually a kind of a collaborative robot. So this is a car robot. So last session we have discussed about the universal collaborative robot. See, the application is very cool. How precise your gripper is, how they are handling the fragile material. I think this application is nowadays very much required because of this COVID situation and all. I think robots are used in food industry also, apart from the manufacturing industry. See here, it is grasping an tool shank from a tool pallet. This is an tool shank used in a milling machine, and they have specifically mentioned the universal robots. This is the translation movement. So this is another company. They're selling pneumatic grippers, just back gripper claw, magnetic grippers.
Sir,
Yes, ma'am.
you have stopped the video, sir. It's not. It
It
is
is not
paused.
playing, ma'am.
It is paused. Yes, sir.
No,
You have dropped my.
problem, ma'am.
No, it is not, sir.
We will. Yeah, no. Okay, okay, no problem, sir. We'll move to the next slide.
Okay, okay.
Please wait for a while.
Yes, sir. Yes.
Yes,
Okay,
sir, it
yes,
is
thank
there,
you.
Presentation.
sir.
Thank you. Yes, okay, thank you. So the last part of my session is about the factors for selecting a proper gripper for your requirement. Right. So these are the factors you have to consider while selecting the gripper for your application. Right. So there are several factors are involved. The first and foremost one is what part you are going to be handling, right? So when we talk about the part, these are all the considerations. So you have to consider the weight. That is foremost thing, right? So based on the weight and size only, you are selecting a gripper. You can able to find out the gripping force. You can able to check the jaw size, right? The weight and size is very much important. And the second thing is shape. So maybe for common shape, maybe a rectangular or a cylindrical. Sometimes it may be a irregular shape also. In such cases, you have to consider the. I have enclosed. And the third is changes in shape during processing, right? So during grasping also, during holding your component also, the dimensions may change, right? For example, if your object is the rubber material, while doing in grasping action, definitely there may be a change in shape that will happen during grasping. So you have to consider that also into the account. Then only it will grasp and place your object in a proper way, right? And tolerances on the part size. Suppose you want to load and unload your component. For example, you want to unload your component from a machine, right? So it is a 50 mm diameter rod. So first time it will give 15.1 mm, and then maybe the next time of manufacturing it may give 51 mm. So in such cases, your gripper should compensate the tolerance also, right? That's very important, right? If suppose your jaw only move for 50 mm, then it cannot able to grasp your 51 mm diameter object, right? And the surface conditions also very much important because some surfaces may be rough, so it is easy to handle, easy to grasp. You can avoid the slippages. Whereas if your part is very smooth, very has more surface finish, so in such cases you have to give more gripping force in order to avoid slippages. That's all. But also you have to consider. Okay? And when we move to the next factor, actuating method, right? This we have discussed, right? So you can actuate by means of a mechanical fingers, right? Mechanical fingers, or you can go with a vacuum cup, right? If your material is a light load application, uh, you can go with this, right? For example, if you want to grasp a glass, so glass you cannot grasp by using a mechanical finger because it may scratch on your glass object, right? Or if you want to handle a ceramic tile, so in such cases also you should not go with the mechanical gripper, right? It may break your ceramic tile. So in such cases again you have to stand with a vacuum gripper. Or suppose if you want to grasp a magnetic material, right? So you have to go with a magnet gripper. There are permanent magnet gripper is available, electromagnetic gripper is available. So you can select based on the environment, based on your requirement. And there are other methods also available that you have discussed last class itself, like adhesive scoops, hooks, etc. And the third important factor is power and signal transmission. That is very important, right? So most of the robotic grippers are actuated by pneumatic actuators. So you have a reciprocating cylinder. You have to give the compressed air at one end so that it will do a extension and retraction. So during extension, the gripper finger may close. During extension, the gripper finger may be open, right? Or you can use some electrical actuator like a motor. Right? If it is a screw mechanism, if you want to provide a rotary motion to the screw, in such cases you can use this electrical actuator. Or if your load is very high, you want to lift a 10 newton, 10 ton low. In such cases, pneumatic actuators won't help. So in such cases, you can go with a hydraulic actuator. Sometimes mechanical actuation also. Very rarely we are using because all are automatic, so we won't use mechanical actuation. Mechanically operating your gripper, that is not possible. And when we talk about the gripper force, so the next factor, the fourth factor is gripper force. We know very well about this because last slide we have discussed about this. So the gripper force again depends upon the weight of the object, method of holding. Method of holding means whether you are constraining your object by replicating the shape in your finger or by means of a frictional force, right? And the third one is the coefficient of friction between the finger and your object. And the last consideration is the speed and acceleration during your motion setting. That is your factor G. And if you want, you can add the factor of safety also during the consideration. Right? And when we talk about the service condition, the important factor, right? You have to mention the number of actuations during your lifetime of the gripper. It's very important. Right? So whether it will work for 10 million cycles or maybe lesser than that, or if you want more than that, you have to consider that also. That's very important, right? And replaceability of wear components. Mostly your finger pads are contact with your object, grasping object, right? So definitely due to the wear, you have to replace your finger pads regularly. So that provision will be provided by the manufacturer of the grippers, right? Then only you can easily replace. If suppose that provision is not done, then you have to completely remove your gripper and you have to use a new one. That is not required. That's a cost consuming process, right? And the maintenance and serviceability should be very easy, right? So the gripper design should be simple as possible. Then only you can do a maintenance. Then only you can do easily. You can service, right? So these are the factors consideration when we talk about the service condition. The next one is operating environment, right? That's almost important, right? So suppose it's an it's a heat and temperature environment, right? Then you have to use a proper material while manufacturing your gripper. For example, you are using in a foundry, right? So especially in a molding section, right? Or melting section, sorry, melting section. So in such cases, if you use a magnum polymer based gripper, then definitely what will happen after 1 year, the property of the gripper gets loosened, right? So because it is constantly exposed to the heat environment, then the gripper will fail quickly. Right? Even if you use a permanent magnet, you use a permanent magnet to grasp your object. If it is prolonged exposure to the heat environment, then it will lose its magnetizing property, right? So if suppose the environment is oily environment, then in such cases you should not use electromagnets because electricity is involved. There may be a chance of spark, there may be a chance of fire because completely an oily environment. In such cases, you go with some other gripper, maybe a pneumatic gripper or maybe a permanent magnet gripper. You can go, right? And humidity, moisture, maybe sometimes dirt, very dirty environment. So in such cases, you have to cover your gripper completely, right? So that's also very important. So the operating environment is very much important while selecting the proper gripper. And if it is a heated environment, then definitely you have to use some heat seals. Heat seal means you have to resist or you have to prevent the heat transfer to your finger. So you can use long finger also, right? So long finger also you can reduce the heat transfer. Or if you want, you can do a cooling also. Maybe a compressed air or water cooling can be done on a gripper. Right? So for that you have to do some machining for the passage of your coolant. So that's an extra work you have to done. So if you want to work in a heated environment. And when we talk about the fabrication material, it should be high strength, it should be a good rigidity, durability, right? And as I said, it is working for 10 million cycles, so it should have high fatigue strength also, right? And the cost, and it should be cost should be minimum, and it should be easy to fabricate. So if it is a machine, then you can use any conventional machine to make a gripper. If it is a titanium, then you have to stand with some particular machines, right? You have to use a proper tool, you have to use a proper machine, right? So there are many things are involved, and the friction properties are also very much important. So you should have high coefficient of friction, right? So then only you can grasp object without slippage, right? So we have to maintain a good coefficient of friction. And when we talk about the other consideration, apart from these, you have to use an interchangeable finger. So that interchangeability should be provided by the company, right? So if it is become weird, then you can change it, right? So that interchangeability should be provided by the manufacturer. That's very important. And mounting connections and interfacing with robots also should be very simple, right? So if you have a pneumatic air supply or you have to interface with the robot, that should be very simple in nature. So like a plug and play. And the lead time for design and fabrication, if you want to order a gripper, the lead time should be very minimum, right? And the spare parts availability, maintenance, and service engineer availability also should be considered. For example, if you are buying any home household appliances, you are not finding any service engineer, then it's very difficult one, right? Very tedious process. You cannot use that household appliance for a long time, right? So the service also should be considered while uh, selecting a gripper for your application, right? So, and I think the magnetic gripper, hooks and scoop, aggressive gripper, these all you already discussed. And the gripper actuation also, maybe you may discuss, you can use a manual actuation method, that is we'll call as mechanical actuation. Electrical actuation also you can perform. So here the actuating force comes into the picture, right? So if you know the activating force, then only you can select the appropriate prime mover or appropriate actuator, right? And maybe electric actuator or pneumatic actuator or hydraulic actuator. So these are some of the schematic diagrams. So maybe also each gripper, that is each actuator has own pros and cons. So maybe you may know already. And these are all some of the tools. So when we talk about the end effector, we have discussed only the gripper part. So these are all some of the tools part. So for doing a spot welding, for doing an arc welding, doing drilling and grinding, cutting device, even you can do spray painting also. So these are all the tools which are widely used for the robotic industry. So, plus, thank you. So if you have any queries, maybe you can raise now.
Participants, the forum is open for questions now.
So I think we have detailedly discussed about how to find out the gripping force and the actuating force. That is very much important. Maybe in all the companies, they have own catalog, right? So once you know the weight, once you know the coefficient of friction, and once you know how you are going to operate your robot, then your task is very, very simple. Even a layman can select a gripper from the catalog, right?
Very true words, sir. Even though I am from electronics background, I could understand the basics of grippers today.
Yes,
Thank you
ma'am.
for the orientation.
Thank you, ma'am. And
Yes, sir.
thanks for your opportunity to speak in a AACT faculty development program. Thank you, Subhasini ma'am, and thank you, Radhia ma'am, for your opportunity.
Happy to have you, sir. Thank you for sharing your knowledge with our faculty members. I hope
Yes,
that will
ma'am.
reach the students also.
Yes, ma'am.
Thanks, sir. Thanks for the cooperation.
Thank you, ma'am.
And we
Thank
are a
you.
team and we are not supposed to thank each other.
Yes, ma'am. That's also
Looking
true.
forward for the next batch also. Thank you, sir.
Yes, ma'am. Thank you, ma'am. Thank you.
Thank you, sir.
Ma'am, thank you so much, ma'am.
This
Thank
session
you.
very nice.
Sir.
Yes, sir.
Thank you, sir. Thank you.
Thank you,
Oh,
Suresh
thank you,
sir
sir.
and Bindu ma'am
Thank you,
for
Suresh, sir.
joining.
Bindu, ma'am, thank you.
Yeah, thank you, sir.
Suresh, sir, thanks for sharing your knowledge with me, and thanks for Vishwapriya, ma'am, also. So, he's also helped me to prepare this presentation. Thank you, ma'am. Thank you all.
Thank you,
That's
Gosal.
it. Let us all join back by 1:55 p.m. for the afternoon session. Thank you all. Have a good lunch.